Hello, this is Fahad and we're doing week 8 industrial boiler introduction. So now we're done with residential boilers and we will transition into industrial boilers and see what is the big difference and what is the big deal. Okay, let's look at them. So first, why do we need industrial boilers? First of all, we need it because we still have a big use of steam, whether to generate power or to clean or to have any other applications or even to dispense heat. So we still need to have boilers in large scale, and mainly also for power generation. I've said before that we're still using steam turbines to generate power. The steam turbine will turn a big alternator and that will generate power. So that's why we still need steam and we need big power. So this is how we transition. Is going to be the same control. If you have guessed, we did work on steam. For residential, it is the same idea. However, in this time, we will need different controls. So for the flame, for example, we can't use the CAD cell anymore because we need faster reaction time, and we also have very much higher temperature. We need more pressure control because we're no longer working with 2 psi or 15 psi. This is going to be a lot of pressure, so, and mostly for power plants, so it's really more sensitive to pressure and how do we operate. And we also control the flow operation with low and high pressure. We need a lot of safety lockouts, meaning that if anything goes wrong, we need the whole thing shut down. Again, we are working with a large amount of fuel. So again, we need more sophisticated controls. For example, adjustable firing rate. So meaning that I want to be able to control the firing rate. So I don't want it to be only one nozzle and one control and that's it. So we can control the firing rate as we go along. We also would like to have adjustable sequence of operation. I will talk about that more elaborately next week. What is the sequence of operation? And probably you are familiar with that because we did something a little bit similar to that in the last portion of the class, where we did pre-purging. We had the flame comes on, then we detect the flame, then we shut off the ignition, then we turn on the fuel valve and so on. So that's something also going to be an addition. And also we need something that is programmable, that we can go inside and change the sequence of operation as needed, and we can go and record errors and see what happens. And we need more input. Again, we're working with multi-thousand BTUs. Okay, so industrial boilers, they are considered a pressure vessel, meaning that they should be designed to be able to handle large amount of pressure. Water is fed into the boiler to be heated and generate steam, and it's for industrial, it's mostly high pressure steam. We're talking about from 15 psi all the way to 400 or 500 psi, which is a lot of pressure. The capacity for these boilers are measured in horsepower, which is a better way to express it than BTU. So a boiler horsepower is 33,500 BTU hour. So it's just a bigger way to express large amount of BTU production. There are two major types. If you took power plant, or probably you have to take power plant at some point, you know that there are two types: fire tube and water tube. And now we are talking about the heat exchanger. The heat exchanger, and how is it designed? Do we run the flue gas through the tubes, or do we run the water through the tubes? There are different configuration based on the design of the boiler. Water tubes, they have larger capacity. Why? Well, if you think about it, if we are going to generate steam inside the tube, having the pressure from the inside of the tube acting symmetrically through the pipe will enable us to have more pressure. If we have the steam from the outside, it's easier to crush in the pipe than to expand it from the bottom, from the inside. So that's why remember that higher water tube have larger capacity, and the reason is because we want to maintain the steam inside to resist pressure. and probably this is one of the questions you will see in the homework. What are flame rods? So we covered the type of boilers, and if you take power plant, probably you'll go in depth with type of boilers and how they are configured. But now for the flame rods, what are they? It's a new way to detect flame. They're not optical, they don't sense heat, they don't sense light, they sense ions. And a lot of you in the first portion of the semester, we're talking about what do we produce when we have fire. We have flame, we have light, and we also have ions. So this invention came about as a mean to detect flame and the amount of flame as well, and that is dependent on the ions coming out of the flame. And rectification, if we ever thought about rectification or heard about it before, probably you know that a rectification system has something to do with AC and DC conversion. So this is how it operates, and I will talk a little bit more how does it do that. But you have to know that it does convert AC to DC, and that's the process of rectification. It has very fast reaction time, and we need that because it's a industrial boiler. We are pumping at least 3 or 4 gallons of oil in a minute, and also we are pumping a lot of gas in a big chamber, so we want to react quickly before whether we have flame or not. We cannot leave the chamber to be filled with fuel. They also can withstand heat up to 2000 degrees Fahrenheit. That's magnificent because we want the flame rod to be inside the flame, touching the flame, and the temperature there can get up to 2000 degrees Fahrenheit. And we did say also it's a pressure vessel, so pressure can build up more heat. They can be right on location. They're not looking at the flame, and they're not away from the flame. They're inside the flame, so they will tell you the intensity of the flame while it's burning. Thermocouples or bimetals that can be away from the flame, they just only sense temperature, and that's not what we are looking for. And they also have longer lifespan. Flame rods also, you probably you can see them all in some gas burners and residential because they're becoming more and more popular. Okay, those are flame rods. What is it? What are the requirements for a flame rod to work? We need first stable flame. It has to be stable. Adequate ground area. It has to be large. And so if this is my flame rod, they go all the way up to 30 inches. So we need the flame to go through it so we can detect the ions. Proper location inside the flame envelope, meaning this has to be inside the flame, not outside. It has to be engulfed by the flame. The circuit will carry the flame signal to the amplifier in the primary control. So the primary control will send AC in here, and it will get into this wire, and it will get DC. Based on the amount of rectification we get and the DC voltage we hear, that will tell us how much flame is in. Properties. So soot can be a problem because again we're trying to measure the amount of ions, and if we have soot, we have coat, and we have prevented the steel rod from detecting the flame. Also, stainless steel allow a maximum temperature of 2462 Fahrenheit. That's pretty hot. But if we have to go more than that for some reason, we will need a different measuring tool. Size, they can vary from 3.5 inch all the way to 48 inches. And we want them as short as possible. Again, for convenience, and also because remember we want it to be engulfed inside the flame envelope. So the 3.5 probably you find in a small residential gas burner. Okay, this is one type. It's the flame rod, which also called the rectification system. Here we also have optical detectors. They are material that can sense light, so either we can see visible light, infrared, or ultraviolet. CAD cell, for residential, they can see only visible light. So any light will be activated in the CAD cell. Infrared and ultraviolet, they are different, so it's only available in flame. So if you put an infrared in front of a light bulb, probably it will not activate. A photocell is a different way to measure or to detect flame, and the photocell generates voltage. So the little photocell in your calculator is generating voltage. The solar panels on top of the house, it's also generating voltage. So it's a good way to generate voltage based on the amount of light coming out of the flame. So they have good view of the flame, that's a requirement, and portion from the refractory light, so to compare whether I'm seeing flame or actually the light from the room. Temperature has to be less than 165. So you can see it can be used, but you have to look at the flame, can be close to temperature. So remember this, because this is one of the questions that's going to be on the homework and also on the quiz. It's good to know these temperature limit. So we talked again about the light spectrum. We have here our visible light that you see from a light bulb, ultraviolet and infrared, as you can see. Different kind of infrared, and when you have flame, actually you'll have all of these light spectrums: infrared and also ultraviolet and visible light. However, depending on the intensity of the flame and what fuel you're burning, you might have different colors, so we want to detect all light spectrums. Okay, uh, move on to explain the process of rectification, but I will pause here and I will record another video.